Have you ever driven to a parking lot only to arrive and find that it was already full, forcing you to turn back? If parking availability could be checked in advance, such unnecessary trips could be reduced. Nagoya University, in collaboration with Kasugai City, has installed LiDAR sensors at public parking facilities. By utilizing these sensors, we have developed a service that allows users to check real-time parking availability through a smartphone application or a web page. In addition, we are also exploring applications for automated driving in parking lots, commonly referred to as automated valet parking. By using LiDAR sensors installed in the infrastructure, it becomes possible to detect the movements of pedestrians and vehicles, even in areas that are not visible from the vehicle itself, enabling safer and more efficient driving. Parking lots are environments that are subject to significant changes, such as nighttime conditions and rainy weather. When cameras are used to estimate parking space occupancy, recognition accuracy may degrade under such conditions. For this reason, we focused on LiDAR sensors, which are less affected by environmental changes. LiDAR emits laser beams and determines the position of surrounding objects based on the reflected light. As a result, stable recognition performance can be maintained even at night. At the public facility Grupo Fujito in Kasugai City, 3 LiDAR sensors have been installed to continuously monitor the entire parking lot. The data from these 3 sensors are integrated and utilized for services and experimental evaluations. First, we introduce a method for estimating the state of parking spaces using LiDAR sensor data. Based on point cloud data obtained from LiDAR, the degree of occupancy within each area of the parking lot is represented as probabilistic information. By combining this probabilistic spatial information with a high-definition map of the parking lot, it is determined whether there is sufficient free space for a vehicle to park. Each parking space is then estimated to be either available or occupied. The estimation results are provided to users in real time via a smartphone application and a web page. This allows facility users to check parking availability in advance, thereby improving overall convenience. Next, we introduce an application of the same LiDAR sensor data to automated valet parking. Automated valet parking is a technology in which a vehicle autonomously drives and parks within a parking lot on behalf of the user. By incorporating infrastructure-based sensor information into the path planning process, safe and efficient driving paths can be generated while taking into account the presence of other users and moving vehicles. First, we evaluated the effectiveness of the proposed method in a simulation environment. Furthermore, demonstration experiments were conducted in an actual parking lot environment. By utilizing sensor information from the infrastructure, it becomes possible to achieve both safety and efficiency, even in situations that are difficult for an individual vehicle to perceive on its own. For the parking availability website, please refer to the link below.